Shruti. I'm working as an integrations engineer at NeonEVM. And first I would like to tell you about my journey and about what I do at NeonEVM. So I started with the Web3 industry 4 years back, and I started learning about it. I'm still a developer, and I love coding, so I started doing some courses, got quite technically deep into the blockchain technology. And then I landed some internships and jobs at startups, and it's been around 7-8 months for me working with Neon. And there I take care of integrations, which involves providing support, technical support to the partners that would want to onboard on NeonEVM. So yeah, that's my role. And today we're going to be talking about what NeonEVM is, why does community need that, and yeah, just a bit about its architecture, and we're gonna dive technically deep into its functionalities. So we're gonna be talking about challenges of enabling EVM functionality on Solana. So first of all, I would like to ask all of you, like, how many of you guys are developers? Okay, that's a good audience. All right, and how many of you guys are Solana developers, and how many of you are on Solana? Like, first we can talk about EVM developers. Okay, and Solana developers? Okay, that's cool. All right, so what NeonEVM is basically, it's a viable solution for Solidity developers who would like to bridge their DApp over Solana blockchain. So if a multi-chain DApp is there, and they want to onboard to Solana as well, they would have to change their whole Solidity coding to Rust to finally deploy on Solana and have its functionality over there. But what NeonEVM introduces is a solution that allows you to deploy Solidity smart contracts on Solana with approximately no code change. So you can just use all the Web3 libraries, all the Ethereum libraries that is provided by EVM interface, and you can deploy through that over Solana blockchain. So basically, if we talk about what are the benefits and what is it actually, so if like all the Ethereum developers know how Ethereum supports very easy high-level languages, for example, Solidity and Viper. It's very easy to understand. It's quite recommended for beginners, and it has a well-known set of tools, libraries, for example, Truffle, Hardhat, that makes it very easy for you to perform tests, to perform different functionalities, and provides a hell lot of libraries for you to code on Ethereum blockchain. And when again we talk about Solana, so it's a high-speed blockchain which allows you to conduct transactions in very low gas fees. So NeonEVM is basically aiming to combine all these benefits into one platform, and we are building a separate community from Ethereum and Solana, and we are helping DApps to leverage both of these chains altogether. Next, talking about NeonEVM architecture, so it's quite complex architecture, but it's interesting if you get into it. So first of all, we have the NeonEVM user that actually plays in Ethereum-like transactions. And it's a normal user who would use any DApp. Next, we have the NeonEVM client that is responsible for sending those Ethereum-like transactions, creating those Ethereum-like transactions to further to Neon Proxy. Now, Neon Proxy is a software that is used by some nodes called operators who are responsible for using this software to convert Ethereum-like transactions into Solana-like transactions. We'll get more deeper into these topics, but for now I'm just giving an overview about what these components are. And at last we have our NeonEVM program, which is deployed as a Rust smart contract on Solana blockchain. Moving forward, this is an overview of a classical Solana program. So how does a Solana program? Solana program is basically a smart contract on Solana blockchain. We call it a program. So how does it look basically? So it has all these fields, and on Solana, the storage is mostly on the Solana accounts itself. So these are the description of the Solana accounts. Now, if we look at a NeonEVM program, so we have the NeonEVM contract here, which would have all these fields while it is being deployed to the Solana blockchain. And it will have a Neon account that is corresponding to the Ethereum account from which the transaction was sent at the first place. And it will have the Neon contract data, which is another Solana account which would hold all that data into its bytes form. And then we have the Neon contract address itself, which is corresponding to the Ethereum address that we deployed on NeonEVM. Now, if we talk about how Neon transaction can be packed into a Solana transaction program. So if you want to execute a Solidity code over Solana blockchain, we have to find a way to convert that transaction into a Solana-based transaction. And for that reason, we have this overview. So if you look at this Solana transaction, it has an account list, and that consists of the address of the NeonEVM contract that we have deployed on Solana blockchain. It has a list of Neon accounts that are responsible for managing the storage of the contract. It has a list of Neon contracts that are actually deployed from the user's end, and it has the Neon data accounts which are responsible for holding the contract data over Solana blockchain. Then there is this program index of the account list. We'll come back to index a bit later. And then we have this data. Now this data is actually the data of Ethereum-like transaction. So this is going to be packed into Solana transaction, and then it's going to be executed on Solana, and the state will be saved on Solana accounts itself. Moving forward, let's get a bit deeper into NeonEVM on Solana. So let's say I'm a NeonEVM user, and I create an Ethereum-like transaction. For creating a transaction like that, I would have to use some RPC endpoint that is facilitated by the NeonEVM client. And through that, I would create an Ethereum-like transaction. Now we all know that Solana transaction and Ethereum transaction have a much major size difference. So Ethereum-like transaction is really big for Solana blockchain, and that's why the high gas fees is there. And so when we conduct the Ethereum-like transaction on NeonEVM client, it sends it to proxy. Now proxy is actually the software that is responsible for converting the Ethereum-like transaction into Solana-like transaction. And this is done by breaking that transaction into smaller pieces so that it can be deployed, it can be executed in Solana, because it is not possible for Solana to actually handle such a big transaction. Now proxy has this functionality, and it is a major one to execute any transaction on NeonEVM. After that, once the Solana transaction is released from proxy that we converted, it would go to the Solana blockchain, to the NeonEVM contract. And it will interact with the Solana RPC endpoint to do so. And finally, the NeonEVM smart contract will execute this transaction according to the Ethereum-like rules that have been coded as a functionality in a smart contract. Next, we can talk about proxy a bit. Now, Neon proxy, as I said, it is responsible for converting the Ethereum-like transaction to Solana-like transaction. Now, how this actually happens? So, Neon proxy is operated by operators, which we call proxy operators, and these guys are responsible for running this program either iteratively or all at once. It is very rare to conduct an Ethereum transaction in one go on Solana because there is such a major size difference. But operators are responsible for that. So they work, they have this consensus over there, and they work for the fees that is attached with the Neon transaction. So when you send a Neon transaction to Neon proxy, there is a gas fees attached that is pre-calculated by NeonEVM client. Now Neon proxy is actually, it has an emulator that tests the transaction before executing it. So it can make sure that the gas fees that is attached to the transaction is actually the right gas fees that is needed for the transaction. If any point of time the gas fees exceeds, the transaction will revert, and that's how it preserves its atomicity. Next, we can talk about the parallel execution. As we know that Solana provides this functionality of parallel execution of transactions, so Neon proxy leverages this and helps the multiple Solana transactions of one Ethereum transaction to be executed parallelly within the NeonEVM program. So this actually facilitates the speed of the program because we have multiple Solana transactions for one transaction of Ethereum, and that's why we would need it to get executed parallelly. And otherwise, yeah, it would take a lot of time to execute a Ethereum-like transaction. So that's why proxy is meant to leverage this parallel execution over Solana blockchain. Now, how to execute a long Ethereum transaction on Solana? I've told you like Ethereum transactions are quite bigger than Solana transaction, but how does it really execute a long transaction? Now, with this, it happens with this iterative structure of a transaction. So if you can see on the diagram here, Neon Proxy sends the Neon Proxy starts the execution of a Neon transaction. It sends the transaction to the NeonEVM contract deployed on Solana, and it blocks the operator account so that the gas fees won't escape. So that the operator cannot withdraw the gas fees until the whole transaction is executed. So the first round transaction goes to a NeonEVM and it blocks the account. It reads the storage, it reads the data that has come with the transaction, and then it saves on the EVM state and then send results to continue the Neon transaction that is left over. So this way, after restoring the EVM state and sending the results to finalize the final Solana transaction, it would send the receipt. So in between, all the state is temporarily stored on operator accounts that we call holder accounts, and that's why if any time in between it breaks, the transaction state will revert, and none of the state will be saved on the Solana blockchain. So that is what the next slide is about. That why we call that if it's an iterative transaction, then how can we presume that it will secure its atomicity? So atomicity is basically like a transaction should be executed fully or it shouldn't be executed at all. So that's what we call atomicity. Now, how do we ensure this among the iterative transactions? So as I said, when the Neon transaction starts, so let's say there's one part of transaction that we start to execute on the Solana blockchain. It blocks the operator account so that they cannot make a withdrawal in between the transaction until unless the operator executes the transaction fully. So in that case, it blocks the account, and if any point of time, either the operator runs out the funds or if there is any error in the transaction, the state is not saved on the final blockchain. It was saved in a holder account that is a temporary storage for Solana, and it doesn't get saved on the final blockchain, so it never got executed and will revert the transaction. Now, lastly, I want to talk about like who all are building, who all are partners, who all are we collaborating, and this is considerably my part because I'm working on the integrations of NeonEVM. So on DeFi side, we have Microsoft. It's the native app on NeonEVM material, and it will expand to different blockchains later. It's a DEX, and you can perform swaps. You can add liquidity to it, and you can do farming and earn Mola tokens in return. Same is with Elk Finance. It is also a DeFi app that allows you to swap tokens over NeonEVM. Next, we have Soval, which is Balancer, which is quite a renowned DEX, and we are working with them for a long time. So they are also building DEX over NeonEVM, facilitating all the swaps and liquidity providing services. Another one is Ferrum Network, which is a multi-swap platform, and that allows you to swap among different chains for tokens. Next is Lever Finance, Jain Finance. Both are again DeFi platforms which perform different DeFi services with liquidity providing and swaps and DEXs basically. Now for social, we have CoinWise, which is a Web3 social platform. So they're building with us. Launchpads, we have Pulse Finance and DXSale. Dev frameworks, we as I said that we can easily use Ethereum-like frameworks, Ethereum-like tools on NeonEVM. So we can make a project over Hard Hat. Similarly, we can make a project over Truffle, Brownie, Foundry, and it will all work in the same way as it would work with any other EVM chain. Next, for SDK and API, again we can use Ethereum libraries. For integrations, we can use Web3.js, we can use Ethers.js, and we can use a famous OpenZML library as well. For IDs, here we can use Remix. For wallets, also we have integrated with MetaMask, Weldon, Zerion, Kana, and Etherspot. These are the wallets that facilitates user to perform transactions, keep track of the balances over NeonEVM. For bridges and transfers, we have Wormhole and Neon Pass. So Neon Pass is basically a bridge that allows you to transfer tokens from NeonEVM to Solana and vice versa. For indexers, we have Graph, Covenant, and P2P that allows to keep track of the state, keep track of the history over the NeonEVM network. Next, we have for multi-sig, we have fork of Gnosis Safe that allows you to create a wallet that will have multiple owners within that, and you can adjust the permissions of that wallet for those owners accordingly. For Netflix tools, we have Metaplex, and to support tokens, ERC20 tokens over Solana blockchain, we have this ERC20 wrapper that is basically that allows functionality between the SPL and ERC token standard. For oracles, we have Chainlink and Peak Network that allows us to get data from off-chain or on-chain, and it allows us to get price feeds for different tokens for different blockchains. Next, for explorers, we have Neon Scan, that is a native explorer, and we have Block Scout, where you can view the current activity, view the current transactions, view the current state of the blockchain. And for DAO tools, we have XDAO. So basically, to sum up, NeonEVM is a project that makes your life easier for all the Solidity developers that are moving towards want to move towards Solana. And so it's basically a quick step for DApps and users who want to try out Solana without learning any more languages or without putting time into converting their code into a different language just to integrate one blockchain. So NeonEVM solution for those guys. And thank you all for being here. I really appreciate it. And yeah, if you guys want, let's connect. Also, if any of you guys have any questions. Sure, please.
What's the average time it would take to execute this transaction on Ethereum?
Actually,
What's the average time it would take to execute this transaction on NeonEVM?
so theoretically, it's the same as it would take on Solana blockchain, and we are aiming towards a more greater TPS of 2000 TPS of transaction time. And but yeah, theoretically, it's around like how much Solana, because transaction is actually getting executed in Solana blockchain, so the transaction time would be same.
Thanks.
Any more questions?
So I didn't fully understand the architecture of this, but my doubt is like let's say I'm ready to Solana, and there are certain things that are good on Ethereum. Can I use interfaces from Ethereum to add up an existing dashboard on Solana? Is that possible, or is like person wrong?
Actually, I didn't get your question.
So let's say I'm building on Solana as usual, and there are certain things that are very well developed in the Ethereum community. So is it like I can use certain Ethereum codes or certain interfaces based on Ethereum to reinforce my my app on Solana?
Yeah, definitely. Like it's totally compatible with Ethereum blockchain. There are some limitations related to, first of all, again, transaction size, because like it's very large as compared to Solana blockchain. But yeah, according to all the interfaces, all the libraries, it is fully compatible with Ethereum.
I think I need to check all that.
Sure, yeah, please try that. Any more questions? Thank you guys. Thank you so much for being here.